Okay, so get ready, everyone. We have team almost ready to present.
We're live.
Ready, and we're live.
Si quiere, pero we have judges that can understand. Okay.
I would say try to do it in English.
Yes.
Because there's more.
Well, I'm going to try to speak
As much as you can.
yeah. It's not better than
If you have any questions, I can translate it.
Okay.
she's my owner.
Oh, awesome.
When the guy that said to us from the presentation, he said need to start with the story. Why I select that this challenge is because she's my daughter. She don't live with me, but we live in the same town. When Maria hit Arecibo, we try to find them. To my home, I never saw never found. Okay? That's the reason why I say that. Product focus for us, because she is part of idea, she talked with me a lot about the idea. Decrease the data needs of that on communication for the political and government sector, for the problems related education for this source complicated environment in Puerto Rico. And how I have or how I could help with my knowledge with collaboration to develop something that can reduce the gaps to share information or data or to communicate with other people close to us. Consideration of special characteristics, maybe a device that can get long distance transmission capacity. Low cost is important, easy to deploy and relocate, easy to maintain and repair, so energy consumption, portable and low weight. If you want to move from one point to another, it's not easy in that situation. Access for work for people communication, studios, or familiar UX. We don't want something high tech. That is the other reason why we select the device. Possibility to integrate in other system of service, or maybe the system can provide something that how I could use more effectively. The solution that we provide a capacity of integrating into this, or maybe use the applier with UPS or something, another system or a third system, ecosystem with other necessities. Develop or integrate easy UX that is important for us. Easy UX use an that make the the tire. Why I'm going to the tire them. Accessible to modify with reuse. Famous is batteries or energy packs. Like that, because the power energy is constant. And that battery is maintained the charge until it. The LoRa have we have two of them here. The LoRa can connect to buildings. We test here. I stay sit here. but I test the system, but on the for mine. I can make a decision. That's important information. Information about that. About that. In Mark's they use honor frequencies. We try to develop a system like that. Okay. If you want to solve the demo, solve the demo. Okay. I have 3 devices. The devices receive the same information. I try to which one to the McDonald's or to the hospital. On any device. You go maybe a little more technical information than what we have. You want to see in the left side the devices. I have the devices. I maybe that one is connected. But llevo información.
So tell us what's happening here. I mean, maybe you can explain it better in English.
He's trying to connect to one of his devices. He has 3, and right now he's trying to connect to one of them so that I can send him. You guys can see. To his computer.
To his computer.
Or we can even use the tablet.
Maybe you press the
the white one, and he's trying to send a message from this one to another device.
To his computer.
To his computer.
Or we can even use the tablet.
Maybe you press the order connect to other devices.
Okay.
So I don't know what's going on. Yeah. So I'm hitting the button, and nothing is showing up. All right. Okay. So it's fine. It's all. Yeah, we can ask later, right?
It's Q&A.
I have a question. It wasn't clear to me exactly what's going on. So you have these devices deployed in different areas or in my home.
Yeah, or your home.
Right, anywhere.
Yeah.
So with my PC, I connected this device.
With your PC or your tablet or your mobile phone.
Yeah, so any Wi-Fi.
Any Wi-Fi device.
Okay.
Once I connect, I can message and chat between people.
Yeah. Yeah.
Okay. Right. So the device in your hand is participating on the Wi-Fi.
Yeah. It's an order. It used before the device, the Wi-Fi, and when you use the data, using lower.
Okay. Yeah. Okay.
So I guess what device, the iPad is using Wi-Fi.
Yeah.
So
okay. How much time do we have left? Okay. Well done.
So that was great. Thank you to my comments. So,
HDMI or both? Also. Okay.
What, you got a little chat box here.
so please welcome. So please welcome. So please welcome to the stage Ms. America Lopez.
Yeah, the kids like calling Miss America. So I'm coming from Los Angeles because my friend told me that he was going to throw a hackathon a couple months ago, and I'm like, oh man, I'll totally come fly in just to learn because I always wondered about that. And I really enjoyed that empathy exercise we had earlier because it was hard to grasp on the understanding, the overall going on to like what happened during Hurricane Maria, and to be able to participate in the hackathon helped me gain a better understanding of what tools could help people. And one of the things that I was really, the Hector exercise really helped because, they didn't have access to the internet or so, where did they go? And looking at the data of OpenPR data, I saw that they had Wi-Fi plazas, and I looked at that, and it would make sense to have mesh networks and Wi-Fi at these plazas because that's where the people would go to check in with their neighbors or grab what I heard earlier from other people who were part of the exercise. It's like, hey, people take video, and even though they might not have Wi-Fi, they might just airdrop it and then send, and then just share it to neighbors back home and say, hey, they're all right. So I wanted to focus more on the data of like Wi-Fi plazas around the island. But again, like the data that this was last updated was in 2015, so there is a need to crowdsource more data about Wi-Fi plazas. Last night I was also working on an Angular web app that would also help crowdsource potential flood zones. Why would you want to go to the plaza if it's potentially flooded? And there's this great open source tool from India, and I really want to show you what it does quickly. Let's see. If you click in flood, it'll send you a link, and because it really helps to have bots help get that data quickly. Okay. And it will send you one-time link. Currently in Bayamon, right? Bayamon? Okay.
Yep.
Yeah. I was hitting some problems during the night, learning Angular, but you want to be able to know if it's like, hey, it's definitely not meant for walking. Oh, I shouldn't bring my car. Why would I go there? Yeah. And you're able to upload code. This particular photo, you want to know if it's completely flooded, and you got to put your dry goods up and make sure it doesn't get wet, but you're going to meet with somebody there. But yeah, I just think this app would be particularly useful to integrate with the Wi-Fi plazas. That way people can be able to communicate well on bringing supplies for the first responders, for the neighbors, and such. So that's what I've been focusing on. Any questions?
I wish I had more time to actually play with the
So you
networks,
can
but-
crowdsource the photos and description?
Yes, that was my aim. It looks like it's not working, and I prayed to the devil gods it would, but it didn't, so.
They are a fickle bunch.
Yeah. Okay, you got stuck. Okay.
Questions? Claro que sí.
One of the assumptions was that you're expecting Wi-Fi at the classes, which you found via the open MPR data. And the expectation is that families or users of this software will be able to transmit it via the Wi-Fi plaza or in the mesh network that would extend and find this. So it needs a backhaul basically.
Yeah, it does need like a backup, so that, you know, maybe the initiative is to have these mesh networks at these plazas, so that way, you know, it's not gonna be completely true mesh network. Somebody was saying like, oh, mesh network, then point somewhere, I forgot what you said, but, yeah, it's just gonna come to that point where it's like mesh network and VSAT. And just to be able to have, it's just critical to get the data there as soon as possible.
Okay.
And yeah, I'm just thinking like 2015 really needs an update, yeah.
So, where is this to be deployed? What's your thought on, so I know that a Wi-Fi probably deployed too, because it is a web app, so I imagine a web server.
I was thinking like at first, like people should have an offline map. I was told that first aid responders and several people didn't know how to navigate to the location, so they should be able to download the offline map. That's the big part of it.
Okay, so this is meant to be like living on your phone as an offline map?
It's like location, like just like the checklist for the goods you should have with you. You should also have a checklist of like places you should check in to let other people that you're okay if you're very limited at home.
Okay. And obviously, because of time and all that, I would imagine that. Did you test this on mobile by any chance? Do you have enough time?
This is mobile. This is a web app. Like, this is,
Okay.
yeah.
Yeah,
So it should have been properly on there.
it should, in theory. Yeah, that's very much. Okay.
So like for public awareness, if the authorities are saying like, oh, you know, you're able to receive the supplies at these locations, this should be one of the locations for people to receive their supplies.
Okay. Cool.
Thank you for your hard work doing the hackathon too as well. And I forgot to thank also Team 1 for the hard work. So Team 3, welcome to the stage. Okay. Well, I forgot my juggling balls, like Jose said, and so I can't. I'll do my best to entertain.
And these were the juggling balls. HDMI.
Okay, so welcome to the stage, WeMesh team. Stage is all yours.
We what?
WeMesh.
Weather
Mesh.
Mesh?
Weather Mesh, WeMesh for short.
Okay.
Okay, so let's go back to pre-Maria world. We have a Doppler radar. Isn't it amazing? We can get weather prediction services, we can get all this analytic data. Everything's amazing, but what's the whole flaw in this? It's only one radar. And something like this can happen. A hurricane comes by and it just explodes. What do you do now? Nobody has analytic data. Nobody has weather systems. What do you do? Well, WeMesh comes in, Raspberry Pi, LoRa connectivity antenna, and a Wi-Fi mesh network, and solves that problem. We have two things. have one, a user node. A user node has weather sensors, it has GPS coordinate, it's a member of the mesh network, and it allows the users to gather data from that particular node. Let's say it's at the top of the skyrise, it's in an apartment building, somewhere where you can get good data analytics, and anybody near that particular node can get particular weather data from that node. But let's say, no, that's not enough. Let's get a government node. Let's say we want this at a first response place. We want this at a hospital. We want this at a public school, a refugee center. Somewhere where the government can put a lower antenna with a good antenna device to get long range and gather data from the whole network. You would say, okay, the users will send their information into this government node and it will calculate an average. And that's the information analytics that will be available from that node. So you can pretty much calculate an average for the area the node is in and be able to predict weather phenomena. So now we're going to go towards a demo. And I'm going to lead you with Victor.
Yeah. So first I'm going to show you part of the raw data that's coming in. So right now we're looking at a stream that's going into the master node of all the weather data that we have on two other nodes that are on our desks. We can't move them because they're pretty yeah, they're pretty flaky. But right now the master node is receiving this, is being pushed this data continuously. As they get it, like I think we can see the temperature changing every so often from one of the nodes. And if we look at this, the average that it's calculating right now, that's the temperature inside right now. So it's pretty humid right now. The dew point is pretty high, and the pressure is pretty low, I guess. Then we also have one of the individual nodes calculating its own weather data. Must have died. Okay. So that's basically with the.
You said this was the master node?
Yeah, this one's the master node.
The equivalent to the government node in this case.
Yeah, that's the government node.
Where is that running? On your laptop?
No, that's the Raspberry Pi. I'm connected to that Raspberry Pi over there. So the point of it is, so the master node and all the Raspberry Pis are connected through Wi-Fi. The master node is the one that has the LoRa connection. And what it does with it is, as it calculates the average, it'll publish it to the LoRa network. So that the other micro meshes, or whatever you want to call them, all have the averages of the other meshes. They're not getting all the individual meshes, all the individual temperatures or other weather data within the mesh, because that would be too much take up too much bandwidth on the LoRa network. So we're taking advantage of the high bandwidth of the Wi-Fi and the long range of the LoRa, because it's, think of it as big pipe, so longer pipe, thinner pipe, kind of thing. And that's basically what's going on here. So.
Okay. All this is being transferred into a database at the government node, so you can do analytics after an X amount of time. You can just go back and see, oh, how's the data in this day, or how's the data in this particular time. So let's say we don't have a Doppler radar, but we have our mesh system, or let's assume that there's only one government node per municipality. And let's say that, oh, a hurricane starts in Bolivia. We didn't know about this because there's no Doppler radar. So we get an alert from Bolivia saying something's wrong, and it will alert the nearby node saying something's wrong. And as the hurricane moves, or whatever natural phenomenon moves across the north coast, it alerts the particular nodes that are being affected by this phenomenon, and all the surrounding nodes get a notification saying, hey, there's something going on nearby. Let's say that we make a low budget investment into the municipality environment, and we put it in key points, and we do overlapping on purpose so that there is no central point of failure. If one of the nodes fails, yes, you are outside of the mesh network connectivity system, but you still get your weather system data analytics from your particular node. So even if you're not part of the network, you still get your weather system data analytics. This is a summary of what we have. It's easy to use. use, is you can simply get your analytics data from your particular node, or you can connect to the government node and get your average for the region you are in. It's very portable. You can switch out the casing, you can modify it, you can simply turn it into a portable device with you anywhere. It's easy to deploy, and it's extremely affordable.
So the web server is running on a Raspberry Pi.
Yes, it's running on the government node.
What is your reasoning behind how resilient would it be with a hurricane over it, and how would you plan to make it so that it's working as the hurricane comes?
So the idea with the resiliency of those nodes is that since they're so small and since they're so cheap, you can just basically put a bunch of them anywhere, and $50 or $100 for local coverage is nothing. So you can put them anywhere you want, and as long as you have like at least you can put 5, you lose 2, you still have 3 left, and at least those 3 are still working.
So it's a numbers game.
It's a numbers game, basically.
What database are you using on the Pi? What database are you using?
Oh, well, on the master node, we're just putting a basic SQL database that's averaging everything. But
what do you mean by basic SQL?
It's just
SQLite?
Yeah, it's just SQLite on this one.
Okay.
But since I'm using post-subscribe sockets, you can potentially put in anything you want on when you subscribe to this, because the subscription is public.
Okay.
So
did you say WebSockets or sockets?
Just sockets.
Okay.
I have a question as well. So you have this micro cluster that speak to each other in Wi-Fi, talk to each other in Wi-Fi. The LoRa basically is the one that alerts the other micro.
Yeah.
Okay. So are you expecting a central repository where all these are collecting data, or how do I interface with the micro meshes to get different and particular data from?
In our case, we did not want you to actually get access to every individual node through LoRa, because again, the bandwidth is not that high on LoRa. So if you start asking for every individual node within the micro meshes for their data, they don't have.
I meant the master nodes. How do you reach the master nodes? So
it's just if they reach you, you get the data. They don't reach you, so you don't get the data. But as long as you, the idea is that as long as there are few LoRa networks that can reach each other, those LoRa networks are communicating and storing their data individually. So you can imagine joining this with some sort of launching technology and having it all each LoRa network stores a log of what it's seen from other networks in that regard.
Okay. So you're assuming some other interfacing like blockchain technology or blockchain or any other sort of database, external database where then you can reconcile the data and access it.
Yeah, basically.
So the government node, as you said, is taking the average of all the ones that's surrounding it over Wi-Fi before it transmits it over LoRa.
Correct.
So when it comes to that averaging, let's say there's one device and a sensor on it, but not all sensors, is mechanically destroyed, and so that sensor fails to send out that data. Does that throw off the average? Is the government node know, hey, this isn't right, this is an outlier, I need to ignore this data?
Yeah, and in that sense, like, yeah, it would throw it off, and that's where something like perhaps putting in something like IBM analytics or systems for the machine learning to figure out those patterns. Hey, all these other nodes are saying one thing, and this one node that's very close to these other ones, because you have GPS. It'll say, no, that node is either wrong, or it's inside somewhere, or it's not placed particularly well. But you'll have that since you'll have the log of every other node.
Right, because we could obviously see it as humans, we look and say, that's not right.
Yeah.
But we're going to be busy doing other things. It's going to have to be able to do that.
Yeah, but since you have within the internal mesh all the every single node, you'll be able to see, oh, this node's acting a little weird.
So
my last question to
last question.
One quick last question. So where's the backhaul? How does the LoRa master node upload data to the internet or to the other database?
Well, if there is, that'll be like if for some reason your master node does have internet connectivity, then it would try to put it somewhere. But if it doesn't, then you just rely on what's on the edge. Okay, that.
Thank you.
Thanks.
Well, thank you to Wimesh. So now we welcome team number 4 to the stage. Okay, so Team Spider, the stage is yours.
Well, hi, I'm Carl, and this is Susanna. We started out with the hurricane in Nashville, and we lived in a mountainous region, and it's pretty hard to get radio through there. So we know that because we tether our phones, and even after the storm, it's pretty bad internet. So we're thinking also during the storm, we'd like to have information. And what better source of information than people who are on ground zero? For that, we made 2 tools. First one, can explain this now.
I think we should explain an overview of how this would work. So every community would have a low power local server that could be Raspberry Pi. And okay, you would have can you explain the relationship?
Each community has a server. They gather data into the server, and they can visualize data in their region. And the second part would be a backhaul. The server connects to it's important data that the government needs. It sends it over ham radio, which we implemented on FRS radio. I'll show you that in a bit.
Yeah, and this is for the purpose of getting help into the people that need that. So we made this application, which is based on a leaflet map. So basically, users would click on the area, and obviously this would be offline, ideally offline on every device. Selected location, you select whatever situation you are in that you help with. Report missing person, dead person, water issues, food issues, and so, and then specify some kind of severity. And you would say approximately 5 people are affected by, let's say, lost home, which is not an option. There. Submit that. And is this connected here? No, it's not it. I forgot. Yeah.
There you go.
Okay, you can actually go to the IP address on my machine, I think, and you can submit your own.
The IP is 172.16.
I'll check.
I got it. It's 172.16.100.42, and then you'll go to port 5000, and you can mess around with that. So the second part, a very important part, to getting data out to emergency services. We take the server, main data, I'm going to do the demo over here. You go to a URL, you give it the location of the key you're going to use to send the data as official, and you give it the key. It's using a one-time pad, so the server in the government office on the other side of the ham radio will be checking if that's valid data. If it's not, it'll still accept the message and log it, but not keep it as official, because it's still information. So in that case, we take that pad, I got the string the server generates with the important data. It's just a text string. I'll modulate it into audio and put it through this walkie-talkie on the microphone, which is going to decode it and convert it to the other side.
In the backend, we have a REST API, which is serving all the issues on that.
Listen on the other end, we can schedule this by municipality, by town, and planning and everything. So at the scheduled time, the town would listen on the other end, we can schedule this by town, and planning and everything. So at the scheduled time, the town would send out what they want to do, and I started sending it before I trained on the radio. Small detail. All right, we're listening. We have the receiver radio, which ideally would be connected by cable to the receiver of the community's microphone. And we transmit. Right. We have here one dead person, 4 emergency situations, 2 missing people, and then access blocks would be a set of coordinates. It's all transmitted overall.
Yep. So check the response to the.
This is not the last version of that.
Okay. Oh no, we have here our JSON file with all the situations. That will be your next.
So that JSON file is the one you're transmitting to him?
No.
What's that JSON file?
Not that one particular.
We take the only important things like death count, missing people, blocked access. Send that.
How do you convert the JSON message to an audio?
I'm using a software called Mini Modem. I forgot the author's name, but it's in the code. It's awesome. So yeah, it uses FSK frequency shifting. I decided 200 bits per second works fine.
So it's a software radio implementing ham radio locally.
Not exactly. I'm using the family radio as a carrier because I don't have a ham radio.
But it is a software-defined radio.
You're just really on your card.
Let me ask, what if to actually deploy this in a larger scale? What would be the equipment needed? What do you foresee would be like? Because I see with small walkie-talkies, that's cool for here. What would be like the next step?
Well, a lot of people, not as many as we would like, have ham radios in communities. So we have to, with planning, know who has it, and then have a box with a server with the community data. And you deploy that right after the storm, put it up, solar panels or power or anything. And inside that same server, you deploy terrain data you have about your community. So when emergency services come and they need data because they don't have cellular service, they can get it off of your device. Any old computer or Raspberry Pi still powers it, right?
So, kind of like, how would you kind of prevent fraud of information? Like, say somebody, say if they're inputting incorrect death counts or incorrect, or they're basically trying to get attention to a particular area by manipulating the numbers.
So we use two-factor authentication on that one-time pad. The community leader has half of each number, a 6-digit number, and then emergency services have the other half. In order to transmit an official version of the information, you need to tell the server, well, you need to transmit it with the whole number and what index it's from. So unless you know both numbers and where it is in the pad, you can't spoof it.
Internally, you have a flag that says that this issue has been validated as true and others submitted but not confirmed.
So you simply have trusted reporters.
Yep.
And those are the only people that's in possession of the one-time pass distributed ahead.
Right.
Thank you.
Thank you. So thank you, Spider. Great job. So team five to the stage. So far, how has been the quality of the presentations? Big round of applause if you. I concur. Okay, so imaginary team, the stage is yours.
Well, thank you very much.
Go.
All right. Well, good afternoon, people. We are the imaginary team, and we developed Digital Pi. The idea with this device is that we can use LoRa to create a mesh network that will be used for data aggregation. So we are looking forward to improving what we have done today to actually have give people the ability to basically have emergency data spread around, but not just simply emergency data, but data that they will personally be interested in. Like, for example, during an emergency, people need a lot of stuff. People need, you go into the next slide, please. A lot of things, like for example, they can have issues with the roads, there will be blockades, local areas, there will be issues with water, all of these are issues we have in Hurricane area. And we have issues like with energy, people want to know where they can find gasoline, at which prices, phone charging spots, where they can make humanitarian help, some water oases, where is a doctor available, and all of this data can be found through GPS, but it cannot be transmitted unless we have some long distance network, and this is what we are trying to accomplish with this. We use LoRa to create basically a LoRa gateway, which will aggregate all of the data that is collected using GPS from the endpoint devices. Our current implementation collects data of location with GPS and sends it to the LoRa, and the LoRa stores it in an internal database, which can then be used to synchronize with the Ushahidi network, this part which we have not implemented yet, but that's the plan. And at the moment, we are also communicating end-to-end between nodes, so we don't have to necessarily depend on the gateway to communicate the information. Next slide, please. This is our prototype. Here's the GPS. This is the LoRa module. And currently, besides the GPS, which is live data, we are assuming that the user inputted data through other means, which we will present soon, but we didn't have the hardware to demonstrate it now. But the data collected will then be sent through the LoRa network on the 900 MHz frequency. Here is the gateway, which is a Raspberry Pi connected to a LoRa network, and the data is stored currently using Postgres, but we have plans to improve it by using the CouchDB database system, which allows for decentralized data aggregation. This is a model of our current database. Over here, we have the reports, special kinds of reports have additional data. There's two kinds of reports: people-person report and geolocation-based reports. And of this is associated to the user, which provides you data. These are the systems that we want to use to improve our current system, which is basically collecting some data and sending it data. We want to use the Papyrus e-reading screen, which is an e-paper screen device that will allow people to interface with their endpoints and collect the data themselves, and also have access to the data without spending much energy. Because unfortunately, we can only government who have like immediate access to the computers to visualize the data, but not necessarily people will be able to access much data. So with GPS, we can get data from nearby devices and show that data to them, or they provide such data. And that's our presentation. We are now going to demonstrate the functionality of the device very quickly. All right. Okay. Victor and I are currently holding our receiver, while Victor over there is holding the transmitting device. All right. He's ready to press a button, and he has the interface right there. If you can see that, have you pressed the button yet, please? You're ready. All right. If you can see this interface, this is what we had in this database, and now you press the button. We have received another node with another entry, which holds not being well appreciated, but it's basically the data and the other information. So that's pretty much it. And there we have it. That's like one of the tables in our database broadcasting the information that was requested from the API. And that's it. Thank you very much.
So you have from the LoRa ESP device to where is the aggregator? You said there was a Raspberry Pi also running. Yeah. Okay.
You can over here. It's basically a Raspberry Pi with the main database. It's actually acting as another node, so it's not configured as a gateway per se, but it can the same way transmit this data.
And do you have an interface in front of this yet, or how do you get the data that's recorded?
The data, in this case, it was pre-programmed except for GPS, which is live, and when he pushed the button, the data was sent through the LoRa connection. In the future, we want to improve it by using the Papyrus screens or another alternative e-reader, which will allow us to give people the alternative to provide the information themselves through the network with low energy resources. Any other questions?
Not much of a question, but I'm seeing a recurring theme in which you aggregate data, and I think just an interesting thing to consider is the validity of it. Like it was questions to the other teams, so they report fraudulent data just to take advantage of something. Just a thought to keep open in terms of taking the project forward.
Yeah, well, that's exactly the reason why we want to move to CouchDB instead of Postgres, because CouchDB allows different nodes. CouchDB is a database that integrates an API that allows different nodes to communicate and transmit data, and we notice when there are conflicts and with a set of algorithms to be the most known data, and that data to eventually propagate until in the end, if desired, someone with a gateway, a primary device, will resolve those issues, ask you to resolve an SDN or a Git repository. But in this case, we would like to we want to design the system in such a way that people will upload and download the data that they're providing, so that way we can have that integrated into the algorithm and solve the issue of data inaccuracy.
Well, big round of applause for that already happened. Thank you, team Imagitech. We welcome Team 6 to the stage. Okay, there you are.
Come on, back. Oh, we have a girl.
Okay, so we welcome Adept Relay to the stage. Stage open.
We are Adept Relay, a mesh network app for communications. So when a natural disaster happens, what an app needs to consider is a worst case scenario. And one of the worst case scenarios that happened in Puerto Rico was the Hutado Bridge going down. This bridge was the lifeline to the town. And yes, one of our personas is Lorena, and she needs to get a message out. I need an ambulance. I am pregnant. My water broke. The road is collapsed. I can't move my car. Please help. A problem is how to couple communication and data during and after disasters. So communication drives data collections, which directly affects rapid action. Community members immediately know other community members' priority needs, which is empowering the local community because they are the first to act. Archiving time-sensitive data that can fuel machine learning, because while the community is aware of its own needs by peer-to-peer, neighbor to neighbor, because if Lorena's phone dies, and then her neighbor is able to, so that information can help the community and also outside areas. So rural community knows how to strategically assist empowered locals at the earliest and safest time possible. So our solution is that before the event that a government sends out a PSA and lets members of the community know to download the app. And PSA alerts are targeted for weather, resources, medical, drones. Our novel idea involves drones equipped with Raspberry Pi to fly over predetermined locations such as a church, because the churches were seen as leaders because EMA and the Red Cross were not as responsive as the churches. And with the emojis, it eases the burden on memory constraints. And this effectively couples communication, which drives data collection. So this is a visual representation of what I just described, the public service announcement from the government. And when these messages go out peer-to-peer, It empowers community responders who know who the highest risk citizens are. And this is just a total addressable market of the churches. Not as many drones will be flying over that many churches, but yes.
So when we were thinking through this, we know that coordination centers during the last hurricane, during Hurricane Maria, the churches played a central role, but they were also overwhelmed over time, and their resource constraints became like they needed to communicate out what their needs were. And so we were thinking, let's use drones, which can bypass transportation hurdles, which if you were going to do like by person, those obvious constraints are going to slow things down. Drones can fly somewhere, anywhere within a 30-minute range, and the goal of this is really to get in means of communication opened up for the people in different communities. When we were thinking through how much information they could communicate to us, we took the idea from Lorena, where she is a certain persona, she has certain needs, issues, but there are many other personas during a hurricane, and that type of information can be very verbose when you're trying to communicate it out. So we started discussing the concept of using emojis, which are, they translate beyond English or Spanish or even mute populations. So this makes a higher level prioritization possible, because we know that if you are sick, if you are in need of medical aid, you need to be directed to medicine. You need a certain kind of medicine in fact. And when we know this through the GPS signal given from the drones, we know where they are, and we know when to coordinate and how to coordinate from the medical resources nearby. But there are, of course, a number of other issues that come up during a hurricane, especially when it prolongs over time. And so towards the right, there was, we wanted to facilitate, eventually, facilitate input and output from having drones fly through. The idea is that if a drone has about 45 minutes battery life right now, it could be, the batteries could be replaced. We can implement this again in an hour. So this is not actually a one-time feed. And we don't have to actually direct this one time. You could make a regular schedule of it and enable the individual communities to schedule it and be more coordinated about how much time you should devote to certain researches.
Okay, it's time for Q&A. So judges.
What kind of flight control was on that?
I'm sorry, say that again?
What kind of flight control was on that drone?
So when we were discussing this, it was, we were basically going to give it the coordinates of those churches, the ones which are priority centers that need to be communicated to. We know where those 600 churches are, and finding that coordinate is really critical, but we need to identify which ones are consistently in need. And so what we were thinking is actually to have a fleet of them, but that fleet would need to be, like, their path would have to be organized. What protocol?
Specifications of the drone, actually there was before.
Can you speak up?
Like, so the specifications of the drone were actually part of the board member, who didn't meet here at the moment. So right now what we worked on was how to get the information in and out. So we couldn't really tell you in depth, because this is his drone.
Okay, yeah, because that's why it's more of a hardware question, like the actual hardware flight controller.
Exactly. Like he was on board with this drone, so we don't actually, we wouldn't actually be able to tell you in depth because
it's a custom DJI.
Yeah.
Set, and he bought it's a set that you buy. It comes in, you put it all yourself, and all the sensors were bought individually.
Oh,
but it's all bought. It's not like exactly.
That's all bought.
Yeah.
It's an ACE controller.
He gave me the speech once, so I can't remember.
Yeah. Did you guys figure out how you were going to mount the Raspberry Pi, and how far do you have to be above the church to actually get that data?
Okay.
So essentially,
You can put it down. That's all right.
yeah, we figured out that that involves an equation, because there's a certain limitation of air right spaces that we can use that has other factors like air use of space. So it's like you have the height of the building, and then you have the area that you can actually fly in, and there's there's some logistics with that, and also figuring out altitudes because different areas have different altitudes and then the building height and then just the air.
So it doesn't have to be that close to the building.
Yeah.
Okay.
Yeah.
Cool.
So I have a quick question and I guess feedback for it. So the input that people will give here would be emojis, right? So how would you deal with the population that they don't know emojis?
That's where emojis would actually become like a protocol, where, if Lorena is pregnant, she can just identify with the pregnant symbol, the woman with the belly. And if she can't have anybody reach her, she can just send a helicopter because she knows that an ambulance would signify that we're on travel. So air would be the only way. And the thing is that it's not just send an emoji and your helicopter's gonna come over. That's going to be, it's gonna be like a profile where, you have the app, you have your name, you have your contact phone number, and they can, the emergency responders can actually send you a text or a call and further verify other needs. And with emoji language, the best thing about that is that it's not static data.
So the one thing that I would say for feedback, I guess thinking about the project in the future, I think it's a cool idea. One thing that you can do is with text analytics on the particular devices. So if somebody writes a message and you said it can go across English, Spanish, it understands the context and it translates that to emojis. And then the emojis are the small data size. So
Thank you.
So last team, team 7. Hold on.
Well done.
No, it's just that's detected, yeah.
Okay, so welcome faculty management to the stage. The stage is all yours.
Yeah.
So I'm gonna facilitate this presentation for a second. So I is called a mountain mesh, but what we're basically working on is a mesh network improvement and incentives. We're not creating a mesh network with our project. We're kind of a application on top of existing network infrastructures, but we're primarily focused on helping those with incentive structures. So, for instance, Althea Mesh, who we researched for this project, has a blockchain-based bandwidth payment system so that people who want internet access can pay for it, and people who want to provide internet access can provide it to people anywhere around them for monetary reward. So the problem, we focused on disaster relief as well as network improvement. In disaster situations, people often lose internet service. Mesh networks can often help with that, where traditional grid may go down, people may have batteries, and wireless communication is pretty available to set up by anyone. I mentioned we work with looking into Althea mentioned their incentive system to help us come up with our idea, and that incentivized bandwidth providing allows for competition in space, so there's reward for helping out. Mesh network coverage can often be unpredictable, especially that the technology is so new right now. It can be also hard to start up and know where the spots are that you could get service for now. Our solution is an internet service supporting system, primarily about the mesh network systems. This basically is a system that lets people see information about your connection pseudo-anonymously. You would post a GPS coordinate about your location, and then you would, every predefined time, let's just say once every 10 minutes, once every hour, you would post what's the bandwidth you're getting for the cost. And we think cryptocurrencies, as used in networks like Althea Mesh, are transparent and provide a proof of payment. So when people get their GPS coordinates, we can verify that the GPS coordinate associated with a cryptocurrency wallet that has been paying is relatively trustworthy with its accuracy. In order to, make if you made a bunch of accounts basically that said GPS coordinates are out in the middle of the desert where there's no one, and we're getting service, then you would have to be paying to prove to take that data. And there's incentive to providing your GPS coordinate. Not everyone has to do this, but if you provide your location and the bandwidth rate you're getting, you can let providers or node owners who would maybe like to set up their own node in your area for profit see what is the most optimal location to set up. Why blockchain? Blockchain technology is immutable, so the data you post to it is there forever. It's a trustless storage of data, so there cannot be data manipulation, and it's also transparent. Some incentive systems, like we talked about, already use blockchain as a payment system, so it'll be easy to integrate into this, and that provides financial incentives already does.
Cool. So that's basically why we're doing this. We're building an incentive network or a tool to help nodes understand where to make more money from providing internet service, particularly in disaster areas where it might take a long time to get coverage. So this is our current distributed app. So this is a blockchain connected application. We have a few different features of it right now. One of the initial features is the mesh activity. So just for the sake of transparency, we've mocked a lot of data because we don't have access to our mesh network. So this would be an example of a list of nodes with locations that are operating as internet service providers, the average prices they're charging per minute, and their current status, how long they've been up or down. So this allows other mesh operators to have open access to the network and understand where money is flowing. And in a situation where the money has stopped flowing or the network is down in a location, the mesh operator can see that opportunity and another one can come in and fulfill that service. So in case of an emergency, if the power goes down, there's no one operating, and there's past revenue there, that means that you've had previous customers that are not being serviced. So you can actually use that transaction data to fill the gaps where entrepreneurial entities can come in and fill the gaps where there is demand and there's not service. So this is one other feature where this is kind of a distillation of the activity map you saw before. And it's just basically where the real activity or where the real opportunity is, where systems are down filled. So two more quick things. This is where smart contracts really come into play. If you're a user and you're in the mountains and you need service, you can actually put out a service request in a smart contract
as kind of an escrow, right? So I say, I will put in $200 into a smart contract. That money will be held until a service provider comes, puts up a mesh net data access point, at which time the escrow money will start flowing into that internet service provider. So it's kind of like it manages the money for this transaction. This part of the app is actually next to the blockchain, so we can actually host service requests to our smart contract. But I'll go to one last item, which is the demand accounting system. So this is similar to the request service request, except in addition to a one-off service request, this is kind of like a public bounty. So in an emergency situation, an entity, you or me, or a government entity could place a public bounty to provide service, and the general public could fund the smart contract to operate an internet service provider for that. So imagine if you're in Florida, the United States, or across the world, and you want to help someone with internet service in Puerto Rico during a hurricane, you can actually crowdfund an access point for that specific location. And there's some more details about how the bounty system and the smart contracts work. We won't go into it, but if you have questions, we'll have to answer.
Questions?
So what type of data is being written? What's the transaction history of your blockchain? You've got your smart contract and request for service, but what else is being written in the blockchain?
So the escrow service, so it's a really important part of this bounty system. So the holding the funds, we have some criteria in which the funds are released, right? So that's the most important part of the story of the blockchain. The transaction data we use to determine service outages is actually part of like Althea Mesh's sub-DAO system that they're building out, where there's a distributed autonomous organization that's managing all of these mesh networks, and we'll be able to tap into that and see transactional data over time for each of the nodes in the network, right? So and that's kind of the unknown in the project that we'll have to flesh out. It's not done right now, but that's something we're looking forward to seeing how that integrates. So transaction data plus smart contract and escrow holdings and distributions.
First off, I like the idea around this because money talks. I mean, it's a motivator to get people to do things. That's how it is. There's no denying that. However, you can fund all you want, but there has to be someone able to actually provide that service. So I wouldn't really call this a critique because I'm sure you all would figure this out, maybe, but one suggestion I would say is ahead of time, coordinate with alternative type of ISPs, people who may be able to provide those microwave links, point-to-point, or VSAT. That way you already have someone, so you can have that money, right? But if there's no one to receive that money and has the capability to provide that backhaul, that money's sitting there, that bounty is useless because no one can claim it.
Sure.
So actually having
like futures contracts.
Yeah, yes. Actually having, people who have a predefined list of people who's interested in this and who might be watching this, watching for this bounty, saying, I can go there, I can do that.
Yeah, and part of this is interacting with these different mesh networks that are coming out. There's quite a few of them coming out that are cryptocurrency backed. And the key part about the cryptocurrency part of it is having that transactional data we can review to determine outages and opportunities. Because without that, you rely on self-reporting, and no one's going to do that. No one's going to, unless you really incentivize them to cash payments, no one's going to say, give you the data for free. So we're giving the public ledger data, converting it into a useful service for the people that are actually producing the data.
So I think you could build a registry around the possible providers, right?
That in smart contract.
So that would probably help with the problem.
Nice job, guys. Where's it running? Where's your blockchain running? Yeah.
Right now, this is a private network. So we have Twinkie Wallet. Twinkie Wallet, welcome to the stage. All yours.
Oh, okay. Yeah.
Where's the
basically to solve a really big problem here in Puerto Rico, but right now I'm gonna give it to my friend here that's gonna explain the basic of the problem.
Well, we understand that communications are a really huge part of our lives, but I would argue that an even bigger part of our lives is money. You cannot do anything without money. And one of the situations that I personally went through when Maria hit was that I had no cash on me. And if you have no cash and there's no network, you cannot use your ATM card whatsoever. So Adachimobi is great, no signal, you don't have money. So that's the problem that we saw, and our solution was to build a progressive web app. A progressive web app is basically a web application that you can download on your phone. It does it automatically, so you can later on, without internet, access that application. And our application basically makes transactions peer-to-peer. So if someone wants to offer you a service, you can talk to a person and basically make a contract with them. And next time you're online, that transaction will be completed. Again, not having money is a very important, money in general is a very important part of life. And not having money can mean, life or death for someone. Our process, or the process that we came up with, was basically making a QR code. So anytime you want to do or need a service, that person, the same way I shared with, says, okay, this transaction would be $5, let's say. She writes that into her phone, that generates a QR code, and she shows that to the other party. That party goes, scans it, that you see, okay, $5, fine, you accept it, and then that transaction would stay like, let's say, on limbo until the next time you connect to the network, and then that transaction would complete, even if you're not inside the application. So with service workers and background sync API, the thing is, it's almost like magic. Now, this is the basic interface that we came up with. You could deposit money in the future, not right now. This is not a future that we make. But you could deposit money, whether it be with your debit card, PayPal, maybe cryptocurrencies. And then you would have the options of creating that QR code that we talked about. We have a not working demo out here, which basically we try to make the whole app work, but development that doesn't happen. So here you would say, again, the service will say, yes, I want to make a transaction of $5. When you click it, that QR code carries the information. It has a key that's unique to the user. And when the other party scans it, that key then gets hashed with his own key, creating that unique transaction that no one should ever have the same key. But the problem we encountered was that we cannot read these QR codes. Apparently, making a QR code scanner on the web is really, really hard. So we tried to develop a way of doing this. We tried uploading it, we tried many things, but we found no way of doing it. But the gist of it is there. You can download this app if you go to the website. That link right there, up there. Please don't. But if you go in, I already took it down. You could access this app and you can download it to your phone the same way you would any app, and it would be there. And yeah, basically the idea, but we couldn't make it work.
Okay, so one of the main technical hurdles was just that the platform isn't there for you to actually scan. So maybe
if we have more time, we can make it native on any phone, and that would work.
Exactly. So can you talk? Did you guys get to do any database work?
No, we did not. We were thinking about using the AVM cloud, but last night when we tried to do it, we couldn't find anyone. It was like 3 a.m., so I don't think you guys. Yeah.
Damn, I got basically for saving the data, we were saving it in the website with the local storage of the website.
Okay, so you're saying all those transactions get saved in the actual app, so you have like a storage of that.
The application is smart enough to know when it has internet or not. When it has internet, let's try to go out.
Cool. Okay.
All right, so you put money in and cash money out
Yes.
later.
And if someone tries to be smart and like outdo the transactions, then they cannot access that money because next time they do, that money is gonna go back.
But if I pay $5, I don't have that $5 anymore.
As soon as you don't have to.
Yeah, you don't have.
So basically, it's like a queue. Any transaction that you make, it goes to the cloud or whatever. It stays there on your phone, and they just stack. You have this queue, and when you go back online, that queue is then like pushed into the server or whatever backend we have. Yes.
How will the other person know that they have sufficient funds?
That's exactly. Because it's a contract. We believe that because of the way this technology works, we would have to do it. We take the money from you as soon as you press it in. So if you scan it and you don't have the money, it wouldn't make the contract happen.
We usually have that, so when you have money in the bank, it's going down because you have that already.
Yeah, but while you're offline and you're making other transactions.
Yeah, exactly. If you don't have money right now, you can do something like some algorithm.
Last time you connected to it, we saw that you had a balance. So we know that information. If you have $500 and you make a $600 transaction, we'll say, no, wait, you can't do that because our info says you don't have that much money.
Last question.
So, if I understand that correctly, you're not only managing the transactions and managing the creation of the QR, you're also managing the balance that they have the moment they had connectivity.
Yes, exactly, because you are uploading money to us. You can use anything, whether you need PayPal or whatever. You upload money to here, not necessarily, we're not using their, so you're giving us money that you have here in case of an emergency. Let's say, oh, in case Maria gets again, then we put $100 there. You have them there, it'll stay there. If you ever need them, you can take them out. But
basically, it's not your bank account, it's all
Yeah. Yeah. Okay.
It's basically a wallet.
Yes,
So
a wallet.
you offline get it. It's offline.
Yeah, offline wallet. It's an offline wallet.
Yeah, okay. Thank you. That's very clever.
All right.
All right, with all the presentations we have for today, thank you to all the teams for your hard work, for staying up for 48 hours. Lunch is here, so go and have a well-deserved lunch. And our judges will now deliberate.
Yeah, one last thing, the final decision of the judges is final. It's not to be revision. And we reserve the right to split a prize if we see two projects that are worthy of it. So that's our goal. So we'll let you know when the meeting is over. If you want what you want, and also
That is true.
to get the money from the prize, we will need one person of the team is the one that will be receiving the payment, and they have to register with Engine 4 that they're gonna process the payment. Okay, so this is. No, we're doing Engine 1.
Doing an ICO.
It's a single one. It's a single one.